Okay, so for our first investigation into Chapter 3, which is about quadratics, we are going to compare products of linear functions. So for this investigation, I want you to come up with two different lines. So I want you to come up with y1 and y2, and they need to be different than mine. But I'm going to pick two fairly simple equations. You want to pick fairly simple equations that when we multiply them together, we'll be able to still see their graph. So for my example, I'm going to pick x plus 2, and then I'm going to pick x. So these are two simple lines that I'm going to be able to graph and see what they look like and consider different properties about them. So pause the video and come up with your examples of lines. Okay, so in my example, I have parallel slopes, but different y-intercepts. Hopefully, some of you have come up with perpendicular slopes. You could come up with y3 equals x plus 2, and y4 equals negative x plus 2. That would be perpendicular slopes. Maybe you come up with two completely random lines. So maybe you come up with x and 2x. So two different kind of lines. So within those, you want to graph them. Number 1 says graph two linear functions in the coordinate plane below here. Describe the relationship between those two lines. So besides the slopes, you can talk about whether they intersect, where their x and y intercepts are, a lot of different things about those lines. So again, I'm going to pause the video and let you find your lines and graphs. So now that they're graphed, and we've talked a little bit about what they look like, so these don't cross anywhere. The next part says determine the product of the linear functions, which means product. That means multiply this one times this one. So my new function, I'm going to call it f of x, equals x times x plus 2. And I wrote that specifically like that because I know this is distributive, and this makes the most sense to me to have the x in the front. So if I multiply it out, I get x squared plus 2x, and I can see that this is a new kind of function. It's not linear anymore. We did talk about linear having a degree of 1, and this has a degree of 2. So we want to graph the product on the same coordinate plane. So these I'm going to graph in a little bit on another sheet of paper, but I'm going to graph the product. So this is going to be y equals x squared plus 2x on the same coordinate plane. I'm going to change colors, and because we may not be sure what it looks like, I'm going to do an XY chart, which means I get to pick my own x values and plug in y values. So I'm going to plug in -2, -1, 0, 1, 2, and see what I get. So if I plug in -2 into my function, I get 4. -2 times 2, that's going to be -4. That's going to be 0. So that's one dot. I'm going to do it in pink so I can see it. -1 squared is 1. -1 times 2 is -2. So this will be -1. -1 is -1. Now I have 0. 0 will be 0. And then 1 will be 1 plus 2 or 3. And then 2 plugged in here. 2 squared is 4. These are like separations. 2 times 2 is 4. That's going to be 8. So at 2, I'm up here at 8. And I can see I've got this shape going on. And if I'm not sure what's happening on the other side, I might try to add some new points. So I'm going to plug in -3. -3 squared is 9. -3, so that'd be -6. That's going to be 3. So -3 is 3, and I can see now it's probably going to go up like that. So I can see my parabola. So what do I notice about this? Compare your work to your group members' work. So we don't have any group members' work yet. But I can see this shape, which we've talked about in class. It's a parabola, and I could describe it as, I'm going to say that this is, I had parallel slope. I have an up parabola. How about that? Does that describe it? And it has a minimum value. Okay, so that's one example. Let's take a look at perpendicular slopes. So the second person in my group might have these two lines. They have perpendicular slope, +1/1 and -1/1. These are my lines with the same intercept, but different slopes. I'm supposed to multiply them together, so x plus 2 times -x plus 2. We usually call that FOIL, but it's really just extra with the distributive property. So it's x times both of these. That's -x squared plus 2x when I multiply here. And then when I multiply the 2 by everything, I get -2x and then plus 4. So when I add all this together, my new function, my f of x, is going to be -x squared. These two guys cancel, plus 4. So again, I have a parabola. It's got a square there, so it should have a parabola shape. I'm not sure what it looks like, so I'm going to graph xy. And let's just look at this on the calculator so we can see how to do a table quickly. So on a calculator, to get a really quick table, if you put the function in, -x squared plus 4, and then you check your table, and I've got it set up as ask and auto. I'm going to make this like this, ask and auto. I found it under table set right here. And if I go to second table, I can fill in stuff. So I'm going to fill in -2, -1, 0, 1, 2. Those are my go-tos. -2, -1, 0, 1, 2. And then when I fill them in, it goes ahead and it tells me what's happening on this side. And I can see repeating values, 3 and 3 and 0 and 0. They're repeating values. What if I go one more further out, 3? What do I get? -5. That's interesting. So the table is really quick for being able to plug in. So I'm going to copy the values down here. 0, 3, 4, 3, 0, and I did a new one, 3, -5. Now when I plot those points, I'm going to do it in pink so I can tell what's happening. -2, 0. Look how it has the same intercept as my line. -1, +3, 0 up 4, +1 up 3, 2, 0, also hit my 0 there, and then 3 was at -5. So I can see the parabola shape. So two lines, again, multiplied and made a parabola. But this time, I'm going to go back to my chart. If I compare it, what am I going to say about it? Because it's got some differences. So if I call this perpendicular slope, what's different about it? It's not an up parabola, it's a down parabola. And this time it has a highest value. So it goes up, up, up and stops. Then it goes down. This is the highest value. We call that a maximum value. And then note again that the x-intercepts of the lines are the same as the x-intercepts for the parabola. So that's kind of interesting. Third set, I've got not parallel or perpendicular. I have two different slopes. So this one has different slopes, not anything special. When I graph y equals x, the first line is here. The second line is up to over 1, up to over 1. So it goes like this, and they have different slopes and what happens. So when we multiply these together for my function that I'm interested in, I have x times 2x. That gives me 2x squared. Again, it's a parabola. It's a pretty simple parabola. If I do an xy chart, I can plug in this one easy. I don't need my calculator. -2 would be 4 times 2, or 8. -1 would be 2 times 1, or 2. 0 is 0. +1 is 2. +2 squared is 4 times 2 is 8 again. So I have that same where at this value it repeats. So this is the value at the bottom, and then they repeat after that. So let's see. -2 up 8 is here. -1 up 2, 0, 0, and then we back up like this. So we can see the parabola right here. So in this case, we have an up parabola. So we're comparing again. If we have different slopes, in this case, they were both positive slopes. So they're positive slopes. I have an up parabola. And I have the same x-intercept. This one has a minimum value at the bottom. So hopefully you've come up with some different lines on your own. You may have chosen a more difficult equation for your line. The ones I chose were very simple. And some of you chose some really great slopes, like slope of 4 or 5, but you ended up with a more difficult parabola to graph because your numbers got really big, and there's nothing wrong with that. But again, what you do with your calculator is you go to y equals and change your function. You could even write it in as one line, 4x plus 3 times 5x minus 2, whatever your lines are. The calculator can do the multiplication. And if you go to your table, it will fill in those numbers. And you might have to choose some other numbers. I mean, I can see really close here, we've got something happening where it starts to do some interesting things as far as go down to -6, and then it starts to go back up again. But this gives you an idea of your parabola. It's just a much more complicated quadratic equation that you have right here. But what is interesting is that if you plug in the x-intercepts, which are -3/4 and 2/5. So let's see. I'm actually going to graph them all here. If I graph 4x plus 3 and then 5x minus 2, we can see them all here graphed on the calculator. So we've got a parabola, that was the multiplication. We've got a line, and we've got another line. And these lines you can see have different slopes, but look how they go through the same x-intercept. We had two positive slopes, one was 4 and one was 5. We multiply those positive slopes, we get this up parabola. So we have an idea of what happens there. It has a minimum value. So at the end of the day, you could do this really quickly by plugging in values into your calculator and seeing what happens. Now compare your findings to the other groups. How are the products of parallel lines, perpendicular lines, intersecting non-perpendicular lines, and the product of two equivalent linear functions similar? How are they different? So this is the one where I've given you several examples. You want to see if you can further talk about those different findings of different shapes. And I did a lot for that in step 3. But you want to flesh it out in step 4 and make sure you understand those connections and then we'll talk about it in class together.